Okay, I think we'll get right into it now. So even though she's not here and she can't hear your applause, I think she'll be watching on the live stream, and she'll be in Slack. So folks on the live stream, use your emojis for applause. Folks here, use your hands for applause once again. And for a talk on functional programming in JavaScript, it's the very wonderful Cassidy Williams.
Everybody in Leeds, and welcome to Functional Programming in JavaScript. My name is Cassidy Williams, and you can find me at Cassidoo in most places, and I wish you could find me at Cassidoo in person with you today. I hear there are biscuits and lots of fun, and I hope the rest of the talks have been great. If you want to ever reach out with questions, you can find me again at Cassidoo, and if you have complaints, you can find me at Phil Hawksworth. Anyway, let's get into the topic. I am so excited to talk to you today about functional programming. What is it? Great question. I'd love to answer that for you. Smashing Magazine at one point called it the mustachioed hipster of programming paradigms, which is fair. Functional languages are actually considered to be some of the most loved. If you look at the 2021 Stack Overflow survey, State of the Developer survey, they were really high up there. And also, a lot of popular JavaScript libraries have been adding more and more functional aspects to them, like React and Angular. Traditionally, object-oriented languages like Java, for example, have added a lot of functional support. It's very exciting, very popular. But what does it mean? The definition that I like to go with is that it provides or produces abstraction through clever ways of combining functions. There are three types of programming, and I already touched on one of them, which is object-oriented programming. There's procedural programming, and then there's functional programming. I'm not going to get into procedural because it blows my mind, but we'll talk about object-oriented and functional to kind of explain the differences between them, because you might be more familiar with one or the other. In object-oriented programming, you create objects, hence the name, which are structures that have data and methods. In functional programming, everything is a function. Functional programming tries to keep data and behavior separate, and object-oriented programming brings those concepts together. Jose Valim, who's the creator of Elixir, he made this quote and said this quote, and I thought that it was a really great way of explaining what it was too. Functional programming is a paradigm that forces us to make the complex parts of our system explicit, and that's an important guideline to writing software. I love the way he explained this because functional programming really is explicit because it's very, very modular, and I'm going to get into more of that as we get through the talk, and you'll agree with him, I promise. Okay, there are two things that you need to know to really understand functional programming. First of all, data is immutable. If you want to change your data, like an array of data, you return the array with the changes, not the original. Data stays the same. You don't update variables. It's kind of funky, but stick with me. Also, functions are stateless. In other words, functions act as if for the first time every single time. The functions always give the exact same return value for the exact same arguments. There are three best practices, I would say, for writing functional programming functions. First of all, your function should probably accept at least one argument. It's just take in some kind of property, some kind of variable, whatever you want to call it. Your function should either return data or another function. It could return both, but it should return one or the other. And then also, finally, the most important, don't use loops. Recursion is actually a really cool big thing in functional programming, but loops, no, you don't use them at all. So I would like to get into a quick example so you can actually see code and see what I'm talking about. So let's just say you have a school, and in some database, we have records of all of the students, and they all have a name and a grade point average. If you wanted to write this in the object-oriented way, you might say, okay, we have a class student that has a constructor, and then you would have a name for that student and then a GPA. And then you would want to get that GPA, and then you would want to change the GPA with these methods that you see here. So beautiful. Anyway, this is how you would do it in the object-oriented way. And if you wanted to create a student, let's just say Phil Eaglesworth, you would create a new student object by initializing it with the name and then with the GPA. This person does not exist. If you were to create an array of students, you could create it like this, where you have just a bunch of new student objects that are initialized this way. Once again, these people are not real, and my GPA was definitely perfect in college. Is that how GPAs work in the UK? I don't know. 4 is good in the US, and I hope it makes sense as an example. Anyway, let's just say that we want to change each of their GPAs. We want to increase all of them by 1 or something. What you could do in an object-oriented way is loop through each of the students, and then for each student, you change the GPA or something like that. You could loop through again to print out the new results, or just work with the objects as you wish. This is how you do it in the object-oriented way. Now, in the functional way, it's a little bit different. Let's just say we have our students again. We have Phil Eaglesworth, Cassidy Williams, and Joe Randy. We have just an array where in each part of the array, we have a string for the name and then a number. This is how you might initialize the students, and you'll notice that these are very just plain arrays or tuples or strings, numbers. Functional programming does prefer these very plain data structures or types like arrays, lists, hashes, etc., so that way you don't complicate the data and behavior. It likes it to be very clean. And so we have this, we don't have any special types or anything attached to it. If I wanted to update the GPAs, I could have something like this, where I map across each of the students, and then you can see that in the first one, by the way, when I look over here, I probably should have rearranged my camera. Anyway, when I look over here, I'm looking at the code. At this point, we want to return a new array, and we're, again, mapping it to students. And then we have the student's name, which is that S0, and then that S1 plus 0.1, that's where we're increasing it by 1. If I wanted to make this a little bit more readable, I could say we have these two functions where we have change GPAs and then change GPA, where the change GPAs takes in the 2 arguments, the student's array, and then that amount, and then it could call change GPA for each value in that student array. So anyway, change GPA is to return a copy of the student, which is passed in with the GPA updated, and they each have their own very specific jobs to do. Functional programming really likes these tiny modular functions that do one part of a larger job, where one of these again handles a set of students and the other one handles each individual student. I hope that made sense. When you want to debug functional programming, it's arguably easier than a lot of other programming paradigms just because it is so modular and there's no side effects. Again, whenever you call a function with a certain parameter, it returns the same thing every single time for those parameters. If something were to go wrong in object-oriented programming, you have to think, what other parts of my program could have affected my program's state? We don't think about state in functional programming. With functional programming, you can pinpoint the exact function where something went wrong. I have yet another quick example for you. Let's just say we have a function here called increment, and we have a count. Let's just say we wanted our increment to just kind of be a counter where every time you call it, it increases the count, but we want to skip the number 5. And so if count is if count is at this value, you would just increase it an extra amount. You can kind of see what I'm talking about here. In this program, if you want to test it, you'd have to keep track of the global state of count and then run increment 5 times to see if it worked. It returns something different every single time increment is called, and so you would need some kind of debugger to step through, or a lot of logs if you wanted to step through this function. Now, if I wanted to write this in a purely functional style, I wouldn't have that count variable up there at all, and the pure increment function would just have everything contained inside of itself, and it would take in the count variable. And I think that's the main difference here that you want to pay attention to. Before, we just have increment, and if it's called, it doesn't take in any variables. It just knows that count exists elsewhere. Meanwhile, with this pure increment function, with this functional version of it, it takes in count every single time. The logic inside of it is basically the same, but because it takes in that parameter, it returns the same thing every single time you call it with the same variable. So because of this, you don't need to run this pure increment function multiple times to check how it works. You can easily test the function because it's always going to return the same thing with the same input, and there's no variable actually being modified here. It returns a new value. And remember, it's all about immutability. Now, this isn't to say you'll never use a debugger with functional programming, but by having everything written in smaller chunks and very free from side effects, your errors will be much faster to pinpoint, and then you won't be dependent on the environment that they're being run in. You don't have to care about where the variables might be changing elsewhere. Honestly, it's a lot like math, which you might be saying, oh no, math, when you think about it. But it really, really is. Let's just say we have this math function. We're keeping it simple where it's some simple addition, multiplication, division. If you were doing this math by hand, you could break up the problem by adding and multiplying all of the numbers, combining what's in the parentheses, and then dividing the results. That's exactly what you do in functional programming. I'm going to pull up an example really quick in Lisp. Lots of parentheses, but if you look at this with that math problem in mind, it's a lot like how you do it on paper. Granted, the order is a little bit different, but you can see in those parentheses, we are multiplying the 6 and the 9. We are adding the 2 and the 4, multiplying the 4 and the 3, adding all of those together, dividing everything together. It's broken up that way. This is often why functional programming is called pure. You might notice that I called it pure increment before, because functions run as if they are evaluating math functions that have no side effects. It's just all contained in one set of parentheses in this particular example. When you want to reuse a class in object-oriented programming and add a feature, typically you add a lot of conditionals or parameters and your functions get larger. And if you're using something that is very object-oriented, like Java, let's just say, you might have abstract classes and interfaces that get very robust, and you have to pay careful attention to the larger application architecture because side effects and other factors might affect your program, which we talked about before. In functional programming, it's more of the opposite in that your functions get smaller. Instead of getting larger, they get smaller because they get much more specific to what you want. One function does one specific thing, and whenever you want to do that one specific thing, for example, add or multiply or divide, you just use that one function. There's exceptions in every single system, of course, but this is generally what you see in various code bases out in the world. Now, there are also a lot of languages that are made specifically for this. Like I just showed you Lisp. There's Elixir, which actually at my job at Remote, we use Elixir as our backend. There's Haskell and Scala and Clojure, but we're using JavaScript. And so I actually want to do some examples with you to see if you can figure out how to do some of this functional programming in JavaScript yourself using these rules that I've kind of drilled into your brain so far. So we're about to code. Get your laptops ready. What I'm going to do is I'm going to have you type a few different things, and then I'm going to have everybody pause the video and try to type out the exercises that I show you, and we'll see how this goes. It could be a disaster. Hopefully it won't be. Okay, so first of all, are your laptops ready? Your editor's open? We're doing all of this in one file, or you could do this just in your console in the browser. Up to you. Go for it. Okay, first of all, a very, very simple function. This is a very pure functional function, add, where you're just adding A and B. You're taking in the two numbers and then you add A and B. Pretty simple so far, right? You're with me? Okay, so this is the first exercise for you. What I'd like you to do is write a function that adds from two invocations. And so you have add, which was the first one where you're just adding A and B. But what if you had add F? F for functional, where you have a 3 in parameters and a 4 in the next parameters, and you squish them that way. How would you write that? Okay, I'm pausing the video. Talk amongst yourselves and let me know what you get.
We'll try it for about a minute. I know not everyone has laptops. A lot of people don't. So if you don't, it's a minute of meditation. If you do, you have an opportunity. So we'll give it a minute, see how we get on, and we can always tune this as we go through a few more examples. So I'll start a timer. A minute goes by, thank you. A minute goes by quickly, doesn't it? So, well, depending on your point of view, either you're working furiously and trying to get that done, or you're thinking, this isn't for me. But either way, that was a minute. So, should we continue with the video? Everyone ready to continue with the video, or people still want to keep going? Yes? Anyone wants to wait because they're almost done? Well, people are doing it on their phones and all sorts. Creative. Okay, Jack, we're going to go for it.
Somehow. Okay, I am assuming that you are back after pausing the video now, and we're going to see what you wrote. So if you want to add, or if you want to write a function that adds from two invocations, this is what it might look like. I'm using the function keyword. You can use arrow functions if you want. So first of all, you have this addf function that wraps the whole thing. And then what you do is you return a function that is anonymous that takes in another value. And then you can use the add function that we wrote before to add them together. And so if we were to put 3 and 4 into this like we did before, you will get 7 because it is ultimately adding that previous one, but it's using two invocations. It's interesting, right? Okay, we're going to do one more. Write a function that takes in a function and an argument and returns a function that can take a second argument. So it's very similar to the previous one, except it also takes in a function. Okay, we're pausing and then we'll come back.
Good luck, everyone. All right, we're gonna pause for a similar amount of time and see how people get on, because I know there are some people tinkering with this. And sorry, you can't see me upstairs. I'm just the hello. I'm just the disembodied voice. So we'll come back in about a minute. And we'll try this again. Okay. By the way, this isn't the tech interview for getting into the social later. You will be able to get in just with your lanyard. Okay, a minute has passed. I'm also really enjoying the pose that we captured Cassidy on. She's willing you on. Look how determined she is for you all. Okay, should we continue? Anyone want more time, or are you ready to get back into it? I'm going to get going once, going twice. back in.
Okay, I am assuming that you are back now, and you have written the most beautiful JavaScript of your life. Let's see what you wrote. Here is my solution here. And so you have a function that is passed in with the variable a, and then similar to before, you're returning a function that is unnamed that takes in b, and then you return function ab, only that fun ab, it's fun because it's functional, is the one that's passed in. My variable names are not the best, but you know what's cool about this? You just learned currying. Wow. So currying is when you break down a function that takes multiple arguments into a series of functions that takes part of the arguments. And so as you saw just now, we have this function that takes in another function and part of it. And then once again, you could call this with multiple functions together. I'm getting tired of saying the word function, and it would add that 9 and 3 together because you're using add. And you could make a subtract function and it would do the same thing if you replaced add with subtract in here. Very, very exciting. Okay, now that you understand what currying is, let's do one more. Okay, write a function that takes in a binary function, so a function that has 2 parameters and makes it callable with 2 invocations. And so a binary function is our add that we had before, where it takes in the a and b, and you can pass that in and then have another function that has 2 and another function that adds 3. I know these are all very similar, but I promise we're leading up to something.
Off we go again. It occurs to me I should come up here because we'll start the clock again. Hello, everyone up there. And also, there are people on the live stream that I was completely neglecting who do have the advantage of having Stack Overflow if needed. So, but the clock will start. So here we go for another example. A minute. I'm getting my steps in today, up and down there. Okay, anyone want more time? We ready to go back in? Ready? Yes. I see people doing it on their phones and all sorts. Okay, Jack, we're in.
Okay, I'm assuming that you wrote everything, and let's see what you wrote. Here's the solution. Once again, we are just returning more functions that do more things. And so that liftf takes in the function that you want to pass in. In our example, it was add. Then we return a function a that would take in the 2 from before, return a function b that would take in the 3 from before, and then that last one, it returns the initial function that you passed in and adds them all together. It's kind of cool, right? It's really just layering a bunch of different things. It's kind of piping things together one by one. And I'm not going to get into piping in JavaScript because it is a thing and it's very exciting, but we do not have the time. Okay, now we have one last exercise and then I promise I'll let you go. Using these 3 functions that we've written so far, we have the addf, the curry, and then the liftf. Write a function increment. And I actually did the first one for you so you can see what I mean. Where let's just say you have a function called increment that takes in 5. We want it to return 6. And so if we were to use the curry function that we made, you could use curry and then add in 1. And so whenever we call increment, it does that. Now using the other functions that we've written, write a function called increment. Pause.
You know the deal. Ready? Go. Okay, we're back unless there are any objections. Any objections? Anyone still working? Remember, this is important. You've got to get this stuff right. You won't get out of the building. Okay, Jack, go for it.
Okay, assuming we are back now, these are a couple of the options that you could have done. First of all, you could have done that add f and then just 1 right there and assign it to increment 1. I just called it increment 1 and 2 to differentiate between them. So every time we call increment 1 with a parameter, it would increase it. And then the other one with lift f, we take in that add function and then we put a 1 at the end and we're just increasing it by 1. And so whenever we call increment 2 with a value, it will return that increased thing. Kind of fun, right? This was fun, right? Get it functional? That's right. That's the whole purpose of functional programming. In conclusion, functions can be broken down into simpler and smaller chunks that are easier to read. That is kind of the main core of functional programming. And these much smaller functions, they have immutable data. So again, we don't change variables, we just return new ones. And they're also very, very stateless because they don't rely on other things. And that makes the programs easier to debug because, again, modular, everything is contained in one nice little function. And once again, it is very, very fun. Thank you so much for having me here today. I wish once again that I could be there with you in person, but I hope you had a good time and you learned something. And go ahead and write functions. See you later.